going to have something with a strange title today. No DevSecOps. Now, I wonder what that's about. Let me tell you first of all who I am. My name is Darwin, and I've got a great job. I'm the chairman of 3 great groups in BCS, the British Computer Society, which is also the Chartered Institute for IT. So we have a royal charter as representing the computer industry in the UK. But the 3 groups I'm referring to are London North, London Central, and London South. We have a combined membership of more than 10,000 out of the 65,000 great people in the BCS, all relating to IT. Now, I guess you're relating to IT as well, and love to see you, love to meet you when we're able to get together for another in-person session. Today's is not an in-person session, of course, but we hope you'll get some useful insights from it and will generate more chat and more conversation about this topic and others. Let me tell you first of all about our presenter. Richard Hollis is the CEO of Risk Crew Limited. And that's a pretty unique, well, as is Rich, a pretty unique London-based information security, governance, risk, and compliance management consulting firm. So it's a consulting firm, deals with all of those security-related issues, and they specialize in providing creative, cost-effective, it says here, you'll have to check it out, independent cyber risk management and security awareness training. Now, please don't just take my word for it. Look up Risk Crew and check this out. Get in touch with them and, see if you can do some useful stuff together. I have a great deal of confidence in Rich, who I've known for years now, and he is through and through an IT professional. He's got more than 25 years of hands-on skills. Take a look at his hands when he's speaking. And he's got experience in designing, implementing, managing, testing, and auditing enterprise-level information security programs. Wow. So all that remains is for me to introduce you also to my colleague, David Grundy, who is here pressing the buttons in the background, and also to say that our colleague, Diana, is going to be joining us fairly soon. We've got a number of initiatives, you see, in our 3 London branches, L3, the 3 London branches that I've referred to. And one of the initiatives is on secure IT. That's what this particular session is part of. Diana runs our cyber initiative, and she will be joining us soon and handling some of the questions and so on that you're going to ask. So focus on you, please. If you have questions, if you have things you would like Richard to address, please put them into the Q&A, the chat, and we'll pick them up. And when Richard says it's okay, which is maybe during the talk, maybe at the end, we'll start feeding him those questions, get those questions answered for you. If there's something which merits it, we'll ask you to unmute and ask questions yourself. But we've got the ground rules. Sit back, enjoy, bask in the sunshine if you've still got any, but especially bask in all the great knowledge that's going to come our way. Rich, what do you mean, no DevSecOps?
First of all, you made me very self-conscious about my hands with this hands-on experience here. I'm thinking, I gotta moisturize more. Good question. I mean, development, security operations, and we're going to talk about that. But essentially, Dalam asked me if I had, he used the term useful insights, and I take that very seriously. I'm a very pragmatic, I've been doing this for a long time, and I look at my profession, our profession, if you share that profession with me, and I look at where where we can come up with a simple approach and multiply the return on that. So no sales in here, it's just a pragmatic advice. So he asked me to put together, he said, you know, if you had a group of friends and you could tell them how to enhance the return on their cyber risk management program, what would be the first thing to come to mind? And it's this topic right here. So I put together some material that I'd like to share with you this evening. And essentially it's to discuss a problem. I haven't met anybody, any business, any organization that doesn't struggle with this problem. And I think there's a very simple, straightforward solution, albeit a tag-on solution, rather than, because we don't seem to be able to solve the core of the problem. There's what I would call a plan B. So it's not tongue-in-cheek. It's if you can't do plan A, which is do it right, for whatever reason, and that's an obstacle to you, as I find it is to the bulk of the customers that I serve, then there's a plan B, and that's to do something that's risk-driven prioritization. And so anyway, it's pretty simple. It's pretty straightforward. I call it plan B, and that's what I wanted to share with you tonight. It starts very simply. It starts here, okay? It starts that, you know, with this idea that all information, we know this, all information is an asset these days. Information is a business asset, and these assets, this data equals cash, right? We all know that data equals cash, and this cash we process, store, and transmit in our applications these days, all right? That this data that we process in our applications now has an intrinsic monetary value to the business, all right? That's an imperative that we understand. We understand that because all of these business assets, these things that generate revenue for our business these days, are processed, are digitized and processed in the applications that represent our businesses, and of course the businesses. So they're on our systems and the systems of our suppliers, right? All right, I want to start there because and then you stand back and you look at, all right, so we understand that we, you know, if you're in the sacred brotherhood of cybersecurity, we know that we believe in the onion approach, right? The layered model. We layer our security. So we have tried to protect these assets through a layered security approach across say the OSI model, where we're looking at all 7 layers of the technology stack to protect these information assets that are sitting at the top facing the users in the application. Okay, the application layer is the closest to the end user, and so we throw another layer on the application. So we've got we put all the security controls in all 7 layers, and on the 7th layer, on the application layer, we additionally, you know, to protect this application, we layer this layer with another layer of hosts, firewalls, host detection, intrusion detection, host-based antivirus controls, proxies, segmentation. All right, layer upon layer upon layer. All right, and despite all of this layering and despite all of these controls that we put throughout our systems and in our applications, we still find that these applications are bleeding. Okay, this just knocked me over. This is from Wired just a couple of weeks ago that said in the first 2 months of this year alone, 22 application breaches were responsible for the loss of almost 500 million records, personnel records. 2 months, 500 million in 22 separate application breaches that they went ahead and listed. Okay, the fact is that the applications that you and I process, our digital assets, our information assets, they're wide open, right? They're bleeding like a sieve, and you know, and it's because of this that this statistic has not changed pretty much in the whole time I've been practicing my profession. 84% of all attacks happen at the application level. Okay, when it comes to hacking, this is where the game is played, on the application level. Why? Because it's both the easiest to hack. This is what hackers are, you know, with threat actors are finding. It's the easiest and most direct route into the asset. Okay, i.e. the cache. You wouldn't think so, given all this thing we're doing to layer and protect these, you know, our systems and the applications themselves. But we do, you know, it begs the question, what's the problem? What is the problem? And the answer is pretty simple, that we all understand, is, you know, given that we're putting, you know, all these controls throughout all the layers, we put them on the application themselves, and 84% of attacks still happen at that level. We're not doing something, okay? The game is played on the application level because that's where the holes are. That's where the vulnerabilities are. or our applications are like Swiss cheese. Okay, they're full of holes. They're full of poor coding, backdoors, zero-day vulnerabilities, open source libraries that, full of other coding vulnerabilities that we include. All right, our applications are like Swiss cheese, and I don't know if you're a coder. I don't mean to cause dispersions on your profession. I'm just saying, as a whole, cybersecurity is not practiced in the DevOps, when we're developing and deploying our applications, and we end up developing and deploying Swiss cheese. And it's because of, and it's a fact. It's another fact. SANS is out there saying that almost 8 out of 10 organizations do not integrate security into the life cycle of them writing the code, developing this application, deploying and hosting that application. 8 out of 10 don't do it. And that's why we have Swiss cheese for applications, and that's why 84% of the attacks happen at the application level. All right, we're not doing the basic simple things like segmenting our developers, practicing secure coding, doing code analysis, static code analysis, secure code reviews. We do pen testing at the end of the line, maybe before deployment, if we're that fortunate. But it's a very, very simple thing. If you want to understand hacking today and why applications are so wide open, it's because there is absolutely little or no security built in to the development lifecycle. At the very least, here's my perspective. At the very least, it's what we should be doing. When you look at our threat landscape, and I don't think we do this enough and talk in terms of the bigger picture. When you look at our threat landscape, it boils down into 4 general areas, 4 ranges, okay, in terms of risk and identifying and accepting the risk associated with our systems. All right, there's one, that's the known knowns, the known risks. All right, these are the things that we know, and be patient with me if this is too. All right, the known knowns, these are the things we know that these are threats and risks, okay? Then there's a second category, and that's the known unknowns. There are things that these are the things that we know that we do not know. So here's information we know for certain. Then we also know there's other information that we know that we don't know that information. Could be, it's unknown to us. Then there's a third category of unknown unknowns. These are the things that we don't know, which kind of typifies my life at college when I was young. Then there's the fourth area, and these are the unknown knowns. These are the things that we don't know but are known to others. That makes sense? 4 areas: known knowns, things that we know, the known unknowns, things that we know that we don't know, unknown unknowns, things that we don't know, and unknown knowns, things that we don't know that others know. These are the threats on the threat landscape. Okay, so my point is, we know the types of attacks that our applications are being subjected to. All right, when it comes to our applications, we know what we know. It's clear. We know the threats. We know the attack vectors to these applications. They come from cross-site scripting and SQL injection. We know these. They're found, but the volume and the variety can be staggering, but we know where our applications are being hacked. We know that through OWASP, right? Through the Open Web Application Security Project, who lists, here are the top 10 ways that applications are being co-opted, that are being compromised. These are known knowns to us. All right, they're things that we know about that are inherently in the applications that are being exploited for unauthorized access. Okay, they're known knowns. They're 1/4 of the threat landscape. Okay, but they do not consider, these are just from generic off-the-shelf applications. All right, it's the list of the top 10. It's by all means not inclusive, and it absolutely does not include things that are specific to the design of that application or the deployment of that application. So these known knowns, this list of top 10, absolutely does not consider any customization that we're doing to our application. All right, they're very specific vulnerabilities that attackers, the known knowns that attackers, generic off the shelf, but they do not include application specific customized features which may or may not have vulnerabilities. All right, they do not include the known unknowns. They might have a design flaw that OWASP doesn't have a common vulnerability explained for it, and we haven't considered because we don't know. We're not considering the design and trying to understand its flaws. We're going to a third party. We're going to OWASP and asking us to give them the list of the top vulnerabilities in our applications. And it's a big distinction. If you're doing things like penetration testing and understanding, you're looking at OWASP top 10 vulnerabilities. That's the known knowns. That has nothing to do with any customized feature of the application that we don't know about because we didn't practice any kind of security by design. One more point about OWASP, and I love OWASP, and you should love OWASP. We all should love OWASP. They do us a great favor. But did you know that the OWASP top 10 list has only changed barely by 3 issues in the last 10 years? So what I'm saying is 70% of the OWASP top 10 vulnerabilities have been on there for the last 20 years. Wow, what does that tell you? It should tell you that we still haven't addressed vulnerabilities in our applications that we knew about 20 years ago. All right, this list of top 10, 70% of that was brought to our attention 20 years ago. And what that should tell us is we've got a problem we're not fixing. In a perfect world of absolute security, every year we're getting better and better. We're identifying and building our applications, and they don't have SQL injections and cross-site SQL injection or any security misconfiguration flaws in them. Why? Because OWASP told us two years ago, last year, that this is a critical vulnerability, and we fixed it in this next version. So technically, if we were really good at our jobs, every year this list would be changing. All right, and we'd be cracking into this more, addressing the unknown vulnerabilities. Why? Because we've addressed the ones that were brought to our attention 20 years ago. But the OWASP top 10 list, 70% of it is as it was 20 years ago. And that's proof of our failure. That's proof that we're not doing any security by design. One other issue, and that's to talk about the threat landscape. We know things that we don't know. All right, we know, and it's call them zero-day vulnerabilities. All right, we know, and I use this from a paper I read from a really smart graduate student, a paper I read that talked about, that on average, there's one vulnerability for every 10,000 lines of code that's written. All right, and that's if it's good code. All right, so right now there's currently estimated to be about 3 trillion lines of internet-facing code and applications. And every year, okay, there are 7 more active developers out there writing more code and writing another 100 billion lines of new code. All right, now I'm not good at math, but this potentially means that there are about 30 million internet-facing application security zero-day vulnerabilities that we don't even know about yet. So, bless OWASP and all their insight that they've given us, but the game that we're playing is stacked against us. When you look at how many lines of code that are out there right now, and we haven't even seen the tip of the iceberg of the unknown vulnerabilities associated with code currently being written that OWASP doesn't know about, and OWASP isn't telling us to address it in our secure design, in our development process. Okay, so let's go back to the threat landscape then. So what I'm saying is, all right, that even if we were doing the OWASP and we built OWASP into our development, our application development process, right? And we designed, we coded, we deployed, we hosted, all in accordance with everything that OWASP knew, all right? Our applications would still be fit for only 1/4 of the current threat landscape. So what I'm saying is that, OWASP, incorporating OWASP into the application lifecycle is the very, very least we should be doing to stand a fighting chance against threat actors today, who also are dealing with, known unknowns and unknown knowns and known, we don't see the bigger picture. Even if we were coding to OWASP, we're still fighting an uphill battle. And that's how important the security of applications should be to us. That's how important security by design should be to us. That's how important that addressing the things that we actually know about, like OWASP, and putting them in building secure applications from the ground level up. That's how important it should be. Given the threat landscape, given the things we don't know about, given the things that we don't know about, and given the things that threat actors do know. Okay, security by design, it's everything. It's everything. And I'm still haven't given you the plan B, but I'm saying this is what we don't do. We don't integrate simple security activities into our system development lifecycle. All right, like conduct risk assessments or say this is what the application is supposed to be for. These are basic security requirements. Do some threat modeling, identify the attack surface, segment, and then do best practices like segment coding and use only approved tools, conduct static analysis, code reviews, do some dynamic testing, and then we don't do anything. And it's very, I ask any one of my clients and they said, well, we don't have the time, the money, or the skill set to do it. These are the three reasons that 80% of businesses don't include security in the development process. A, it costs too much. B, it delays our time to market, and time is everything if you're writing code for a new application, right? You're writing a new API, we need it yesterday. The quicker you can go to market, the more money you're going to make. So cost and time to market are essential. And then there's the skill set, is finding the developers who understand secure coding, finding developers who have the tool set, who have the skills.
Sorry, Richard, can you unmute?
Don't know how long that happened.
Just a few seconds. That was my fault. Sorry.
Ah, okay. I take that personally. When they mute you and you're a speaker, you know you're not doing a good job. So I'm saying there's three reasons, right? Cost, time to market, and skill set. This is why we're not doing security by design. It costs too much, takes too long, and we don't have the right people. Okay, anyway. So that brings us to the problem. That brings us to 84% of all attacks happen at the application level. So we have this problem, and what can we do then for little cost that won't slow us down, and we can use the resources we have. All right, I call that Plan B. All right, Plan B. I call it risk-driven application security penetration testing. We're doing pen testing already. Everybody's doing pen testing, and they're complaining about it. It costs too much. It takes too long. We see the same vulnerabilities. Of course they do, because of course you do, because you're seeing vulnerabilities. You're only pen testing against your OWASP listed vulnerabilities. So it only can give you so much. All right, but because it's based on the OWASP scope and doesn't include any customized design features of the application or the deployment features, you're getting a limited return on that pen testing. All right, this is a simple way to enhance the return on that testing by assessing the risks, looking at, based on the design documentation available to you, identifying the specific attack vectors, all right, mapping those vectors and using that as the scope of your penetration testing going forward. All right, let me, it's just 4 simple steps. Let me take you through it and you'll see what I'm talking about. Is step 1, grab everything that you do have on the application on how it was built. Okay, what was the purpose? What's the background? What's the scope? What was the idea? Why did you build that application? What were the functional requirements? What are the APIs, the interfaces? What kind of storage capability? What design documentation did you complete? What libraries, open source libraries did it include? What development procedures did you include? And therefore, by extension, did you not include any security? What security was included in the development? What controls were put in that should be tested or should be confirmed? Any encryption that you had, any validation, access controls, authentication, accountability, all the way down to this application plays a role in your business continuity disaster recovery plan, right? Because it's hosting an information security asset. What's the classification of that asset? All right, and how quickly should that be brought up in your business continuity plan, your disaster recovery plan? Okay, so this step one is just grab all the information you have, put it all together, and understand what is the purpose of this application, what is the security objective, how sensitive is this application to the business. All right, and that means, you know, what sort of information asset you're actually processing, storing, or transmitting. Then you go to step two. Once you have all this design information, you could quickly, and by quickly, I mean not more than an hour, identify, all right, here's the information asset, here's the existing controls, given these existing controls and these lack of controls, then it's a very, very quick risk assessment view of the application. Given the sensitivity of the application, of the asset that it processes, stores, or transmits, you calculate the likelihood, the impact, the application risk level. It's simple. All right, it's information security 101. But you take a risk view of the application. Now, some applications might not process an information asset. So who cares if, quite frankly, if they're exploited? I mean, there's a reputational impact on you, and that should be considered. But that's what I mean. Take a look at the assets and the sensitivity of the assets. Do a risk assessment based on your design documentation, your known knowns, what you know the application affords you, and most importantly, what it doesn't afford you. That's a critical view. And that's a view that any organization should have of any application that processes an information asset. All right, so you've reviewed the design artifacts. You step back and done a really quick risk assessment and just understand the sensitivity of that application and its relationship. So in the event that it was exploited and compromised, what would the impact be on the business? Now you've got a risk view. And more importantly, then you've got something you can start to map, and you can identify the threats and the attack vectors to that application. It could be done just like one of the ones I like is just this mind map here to the right of the screen. This is just where all the connections are, what forms lead to, you know, what access, what authentication, what controls. It's just a mind map of the application. But essentially what you're looking at here is an attack surface of the actual application based on the design of that application, based on customized features of that application. All right, that you've taken a risk view. You've done a really quick risk assessment and said, this is a critical asset, a high asset, a low asset that this application hosts. And suddenly everything should become in perspective, because now you've got, these are the ways to attack that application and get access, unauthorized access to that information asset. What a view. What a view you suddenly have. You suddenly see very, very clearly how vulnerable that access is to exploitation. And this finding, this right here, what you're looking at, this mind map, this attack vectors mapped out, okay, becomes your application penetration test scope that you hand to your outsourced third-party provider. You say, here, use this, test this. These vectors should have these controls in them, or not, because they weren't included in development. But suddenly you've got a risk view with the attack vectors, and the penetration testing you've done, you hand over, becomes a customized pen test based on the design and the attack vectors associated with that application. And you're not doing generic off-the-shelf just testing for OWASP. You're considering all the design features, all the deployment features. You've got a risk-driven view that understands each and every avenue in which you could attack that application, and you hand that over to your pen testers and you say, there's your scope. And when you do that, your return on your pen test report is going to be exponentially, you give you 10 times the return that you're doing on regular, and you're doing pen testing anyway. So now you've got a focused scope, and this is where any client we talk to, we say, what is the scope? Oh, the scope is OWASP. Well, that's good. That's great. You should have covered that in development, but clearly you didn't. But okay, but this completely bypasses. This is doing pen test with no consideration of any customized features in the actual design or deployment environment whatsoever. So it suddenly becomes, your pen testing to me suddenly becomes, square peg in a square hole, round peg in a round hole. It's customized, and you're testing exactly where the vulnerabilities are with that specific application, and not doing off-the-shelf generic testing. And you're compensating. You've documented. Look at what you've done. You know, in those 4 steps, you've reviewed the design artifacts. You've conducted a risk assessment. You've mapped things out, and then you test that map. And you're testing exactly what you've identified are the vulnerabilities. And you're testing it before a threat actor tests it to see if they can exploit it. All right, so you're airing your dirty laundry out, you know, exactly where, and saying, these are the holes in the way I've developed it. You're giving that to a pen tester, and they're giving you back the results. It's a customized scope. What I'm talking about is essentially 3 steps you should take to customize the scope of a really good application level penetration test, and get a 10-fold return. Makes sense? Because suddenly this plan B, if you look at plan B like that, you see, go back to your, hey, yeah, it will cost more, but not more than 10 or 15%. I mean, look at what we're talking about. Can you do review the design artifacts? In terms of time, the biggest amount of time that we see is, can we find all the design artifacts that went into that? And they're never complete, I grant you that. You might have outsourced or open source libraries in that application, but at the end of the day, what we're talking about is just reviewing those. That's not more than half a day's worth of work. Okay, and then moving that over to a risk assessment, that's not more than half a day's worth of work. And then mapping out, and that probably takes the longest. All in all, we're talking about adding maybe 2.5 days to a pen test scope. All right, 10 to 15% markup of that. All right, you will not impede your time to market. You're adding 2 days onto your pen testing at an average, and you're giving it to a skilled security, security set of hands. All right, Dallin talked about my hands. You're giving it to a professional to say, here's where the vulnerability should be. Test these attack vectors. All right, so you're compensating for the skill set. You're not affecting your time to market for a 10% increase in what you're paying for an application level pen test. To me, I call that plan B, and it's pragmatic and it's simple, and the benefits are so clear. You're going to identify the design vulnerabilities that are inherent to that specific application. All right, and you're suddenly doing customized testing, not OWASP testing, which should absolutely be included. And your pen tester should be including it as well, but you're quantifying and you're calculating the risks associated with that specific application. You've got a documented attack surface. Now, can you imagine the value of that document, that mind map that says this is all the ways that this application could be potentially attacked? Right, and you've got that suddenly becomes institutional memory, and it should be associated with that. Right, and you're conducting testing applicable to the risk of the application, and that makes all the difference in the world. And you should be doing that with everything that you do in cyber. But you know, for me, this simple plan B gives you the focus, and gives you the focus of the business. What's important for the business, and this is all it's not driving the pen testing that you and I are doing in the market today. Okay, so I see clear benefits, from a laser focus to a laser return on what's important to the business, because you've taken a view on it. And one more thing, this becomes an institutional memory of that application. Here's the design documentation. Here's the risk assessment that was done on this. Here's the attack vector mapping that was done, and here's the first pen testing. All right, for you, so there you set the bar, a risk-driven bar. And of course, as you do your continuous improvement, and every year try to increase the testing to increase the security integrity of that application, you've got something to work with. You've got a set of documentation to work with, and people are just not forgetting it. And next year you just test for the OWASP top 10, which are the same as the year before. And you stop repeating yourself, okay? Because that's literally what I see us all doing, because if we keep doing what we're doing, we're only going to keep getting what we're getting, and what we're getting from that is an 84% of hackers are coming in through our applications. Okay, I told you it was short, but I have had a lot of coffee, so maybe I've speeded it up. Hope I didn't talk too fast in hindsight. But you see my point. It's very, very simple. Very, I like to think it's straightforward. This, step 1, step 2, step 3. If you don't have the department, you can outsource this and give these tasks to your pen tester. But technically, you say, here's my design documentation. Here's my initial risk review, and your pen tester can map the attack vectors. But think of the difference it would make in your first pen test. That would consider all the design features, all the customized aspects of that specific in light of the information asset that it processes on behalf of your business. It's a pure risk-driven view, and it's certainly what I would advocate if you're trying to get more of a return on your security spend. That's it. We got lots of time for questions or comments or.
Great, that's really good. David or Diana, who is also here now, would you like to pick up on questions from the chat?
Hi, Diana.
Diana, there's no sound.
Sorry, is it now?
Yeah.
Perfect, sorry. I just wanted to say hi, Richard, and thank you very much for all of those insightful comments. There are quite a few questions, so we might actually end up just talking 30 minutes just to go through the questions. They started coming up since the very beginning of the...
Is this about my hair, Diana? Because I don't take questions on my hair.
It's about everything, really.
Okay.
So let's just go through them one by one and see where this takes us, because they might appear more after those. The first question is from Jerome, and he asks if the bleeds in applications are because of pure implementation, or are there layers not fit for purpose as time goes on and attacks evolve?
That's a good point, Jerome. I think it's a combination of the two. Yes, applications age, application technology ages, patches, are laid upon patches, on patches, and applications that you and I once knew 5 years ago that we're still using don't look the same at all. Which is why I think, Jerome, it's important to have that institutional memory about what did the application look like when we first built it? What was its purpose? Now, that's another thing that I see is applications suddenly, where we started out with one information asset, we've added another and another, and we started to multitask these applications. So that changes. But if you don't have that initial documentation, that baseline that you establish through design artifacts and a risk assessment done on the application and mapping, attack vector mapping, that can grow with the application. And every year or every 6 months or however you do your application pen testing, as you make these changes, you build on that documentation. You reassess the design documentation, see the changes you made. You see if that affects your risk assessment, and you see if that affects and updates your attack vector mapping. You see, you keep these documents alive throughout the life, and that solves that problem. Because of just your point, Jerome, because everything changes year after year after year. So you do that, you just pull out your old documentation. Here's my original design artifacts. Here's my original risk assessment. Here's my original attack map, and you update it every time you make a change to that application.
Thank you for that. Our second question is from Dalbir. He's asking if there is too much focus onto network layer firewalls for security, or should it be more relaxed?
No, I absolutely agree with you. For me, there's too much focus on everything that we put in front. My opening slide, 2 slides were about, we work on every one of the 7 layers. And then on the application level, we've got IDS and we've got host-based antivirus. We've deployed all that. And yet still, 84% of the breaches are coming on. It's because of bad coding. It's because of backdoors. It's because of poor vulnerabilities that we're not addressing in the libraries that comprise our applications. It's because we're not addressing it on a code level. So we can keep putting layers on that, but every year after year, we're not addressing the problem. And we're not addressing an application level firewall isn't going to stop cross-site scripting, which is what is OWASP is telling us. Why are we still dealing with cross-site scripting vulnerabilities? That vulnerability is 20 years old. Why aren't we addressing that in the SDLC of the application? And then we would need a firewall, would we? And the firewalls aren't effective for that, by the way. So no, I'm not for me, it's this fundamental granular level issue about writing good code. All right, and putting a firewall on top of bad code doesn't solve the problem.
Then Marina asks you really, do your clients typically use black box or white box pen testing? If the latter, how early in the development process are the pen testers brought in?
Okay, first of all, you're talking to somebody who doesn't believe in black box testing. I'll be right up front. I don't. Why not? To me, that's, here, I'm not going to tell you what I have, see if you can get into it. Now, I can spend a year, I can spend a day, I can spend an hour, okay, on trying to guess what's, so I'm not an advocate in terms of return on investment. Every CISO I know is struggling to get the most information they can on the application. And to do that, I would absolutely sit on my pen tester's lap and show him everything, complete transparency of what you have and what you don't have. Agree on these things like attack vectors and how best to test the application against its security resiliency. So I'm sorry, I'm not an advocate of black box testing. I think that's in nobody's interest except the pen tester's interest, who could charge you time and materials. Well, we'll work on that for 5 days and see what we can do. Yeah, maybe 5 days and 2 hours would have found that vulnerability that was sitting right out for everybody to see, but couldn't be seen in a black box situation. So I advocate complete transparency between you and anybody you trust to test your applications, giving them all the documentation, giving them credentials, having them test it with credentials and without credentials, both as a user and a non-approved user. But at the end of the day, why wouldn't you? Because the return is, the more you know, and the more return you can get, and the more you tell your pen tester, the more return you should be able to get from them.
And then would you suggest to just invite them as earlier as possible within the development process, or?
Oh yeah. Well, first of all, that's not, in the best world, I would say, if you're developing it, you're talking to a pen tester, I would say ask your pen tester for, here's the top 10 things that you should be doing at this phase of development to ensure, because what we're talking about is a lack of secure coding. Okay, so it's the quickest you bring in and out, and if you're relying on a pen tester, you're going to get an exterior view. But if you can bring a pen tester while you're in the development phase, absolutely, as early as possible, as far upstream as possible. Even if you haven't started coding, but you have the design artifacts, and they can say, okay, given the design, take a look at these top 10, these 5 or 6 areas where we think your attack vectors are going to be based on the design. And they'll be doing exactly what I'm advocating you do before the pen testing. They'll be getting a sense of where the vulnerabilities are based on its customized features before actually testing. So the sooner the better is the answer.
All right. Our next question is from Jerome, and he's asking if is AI making wave in the DevSecOps field to help automate the implementation of security system design?
That's a good question. I haven't heard. It's funny. We just at the office here, we were just talking about that yesterday. Because AI's got to play a role. For AI to play a role, you need to say, here's the role I want you to play. Play the role of a secure developer who includes security integrate security activities and controls into the design and development phase. All right, then you could pretty much get a list of all the things you need to do. That's, by the way, that's not a secret. So AI doesn't give you an edge. It would give you, here's a list, just like you could ask it, what do I need to do to comply with ISO? Here's a list of controls. If I were a developer, if I were a GRC manager, here's what I do to comply with, here's what I do to enhance. Now, the problem is to get somebody who knows how to do that and to spend the time to do things like segment developers and buy the code scanning and the tools and things that you need. But AI is going to show you what you're not doing. but anybody who takes the time and the effort can, so I don't see it as insightful, not at this point. At least I haven't heard of it being used for a very clever way to circumvent or to shorten, the amount of time and effort that has to be into actually doing the secure coding. But please, anybody out there hears of something, I'd like to hear it. I've heard it in terms of developing, and you can use it to train your developers. They can check, all right, my next step according to this is to do this. That's fine, but it needs to be built in. The time and the effort needs to be built into training your resources to do what AIs should be bringing to your attention. But I tell you, AI pulls all that information from guys like OWASP.
Our next question is, how can pen testing advise way forth when developers may be aware of the risks in the system, yet business cannot afford the modifications which may be required? Does the approach inform developers more so, or business? Does it facilitate collaboration?
Wow, good question. That's clearly from somebody who works in the real life. Yes. You know what? I think so. What if I understand? And correct me if I'm wrong. If I understand the point being made in the question is it better to is it better to know what you don't know? And I can't help meaning, all right, the business can't afford to fix the things that the pen test brings up, but you know what? The business now knows the vulnerabilities associated with the application and can make an intelligent risk decision, whether to accept that risk because they can't afford to fix it or go forward. All right, that's good news and that's bad news. All right, in the event that application is compromised, you've accepted that risk because you knew you went live with that vulnerability that was exploited, and now you should know the impact of it. And that's just risk management. There's no such thing as a completely as computer security. Cybersecurity is an oxymoron. There's always a certain amount of risk in everything we do. But if you're saying, we don't have the money to hire a pen tester to tell us this thing is full of holes, well, okay, then I don't, okay. But for me, knowing what you should know is very important in terms of accepting the risks associated with that decision. I do a lot of pen tests for customers who the next year, they still haven't remediated the last year. But they've accepted a pen test report to say this critical vulnerability is still there. And lucky for you, nobody's come along, found it and exploited it, but it's still there. And now you know that, and you have a continuing responsibility to manage that risk. And if you don't manage it, then you bear the consequences. And that's what the game's about.
A particular question as well regarding to this is if SAPSA gives a framework for security by design, by any chance?
I love SAPSA. You combine SAPSA with OWASP, and you have the squeaky, an architecture that's built for purpose, an application that's built for purpose. SAPSA is just an intelligent way to build an architecture of a system, okay, that's led by the sensitivity of the assets, which is pretty much exactly what I'm advocating that we do, is understand the assets, understand the application sensitivity based on the asset that it processes, stores, or transmits. That's what SAPSA does for the whole architecture. And that's what you should be doing for on a granular level for every application. So I would absolutely say, Yahoo, if you can take a SAPSA architecture and then practice OWASP best development practices in your SDLC, you've got a fighting chance.
So really a framework would be the combination between the two.
Absolutely. It's the most sophisticated dual approach I've ever seen. And they're both open source, and they're both incredibly effective in segmenting and dealing with things on a risk perspective. SAPSA is an unsung. SAPSA is OWASP for systems. It's incredibly powerful. And would go a long way in minimizing the risk. Yeah, wow, it's good to hear. I don't know, SAPS has been around for a long time. I've known where it's come from, and I wish SAPSA had the success that OWASP does, because the two are a powerful couple.
Our next question is, how can buy-in from developers be brought about who want delivery of their functional solution and not see it as overhead of governance for pen testing, when they may be seen as impeding their own personal development with exposure to different libraries?
Oof. I'm not sure I understand the question. Okay. Whenever you use the word pen testing, to me, I divorce it from the idea of governments, meaning checklist. If you're pen testing because PCI tells you to, and you have to for PCI compliance, this is not, pen testing for me is a risk management tool. It's not a compliance tool. And once you use it as a compliance tool, you come away and you start doing things for compliance and not for actual risk management purposes. To me, it's two different languages. It's French and Spanish. And they're not compatible. Well, they're not. They're just, once you start speaking compliance, you're talking about pen testing in an entirely different terminology. Okay, and that's pen testing for PCI or pen testing for whatever it is. And that's, when you do that, you need to pick up that language and understand you're not pen testing for risk management, you're pen testing to tick a box, which is unfortunately, for me, most people do that. So if you're faced in there, the first question you ask yourself, and you should be telling your pen tester, is, we're doing this because we're really concerned about the security integrity of the application, or we're doing this because we have to do this for compliance to X. And then you play by the rules, but you accept, either way, for me, that's a big conversation to get drawn in, because I don't consider pen testing a compliance tool. I never did. And I get concerned when people talk about it in that sense, because it's not cost effective. It's different outcome and different motive, and justifying a pen test based on cost for compliance is not a conversation that anybody really wins. Justifying a pen test for a return on risk management investment, to me, is the more intelligent argument and the more intelligent conversation. This very first question, I think any pen tester asks the client, is, why are you doing this? And it makes all the difference in the price and everything else. And pen tests are a lot cheaper when you're just doing them to comply to PCI. I don't know if I answered that question. In fact, I'm sure I didn't. It's just to me, they're not, you can't use the same terminology and come up with an answer that fits both.
I think that they are just looking for how to persuade software development companies to take the approach more seriously towards security. And truth be told, I think that, first of all, differentiating the approaches. So are you looking for compliance or security is a very good way, the way you said it. Yeah.
Well, Diana, it is our problem in our industry. It is, what comes, the chicken or the egg? Is this about compliance or is this about security? And you have to ask yourself and give yourself an honest question or an honest answer to that to get real value. I think there's incredibly more value in the return of it on a pen test that is risk driven than there is that's compliance driven. It just is. And I know that pen testers who understand they have to do it for compliance purposes only go so far. They do the minimum that's required for compliance, and that's it. Where just another inch, just another hour of research could have brought them to a huge vulnerability that led to, at the end. And the compromise is a compromise. When applications are compromised, they're irrelevant of if the pen test was done for compliance purposes or for actual risk management purposes. Doesn't care. A breach is a breach is a breach.
Our next question is from Jen, and she talks about just open source libraries. Applications use over 90% open source libraries. It is not possible to risk assess every library. How can we reduce the holes that open source introduces without stifling our developers?
It's a great question, Jen, and it's one I face every day. So first of all, open source is open source. And you know what? Frankly, I'll say something that I know I'll draw a few bad comments. I find open source more secure than commercially written software. All right, because it's had 10, 30, 40, 50 developers look at it and make it better and better and better. Where you don't know the same is whether from that Microsoft or that Salesforce or that software as a service that you're running, that was never open to 40 or 50 different sets of eyes, people building it to make it better. So I first of all, when it comes to open source, I take it that open source is open source and you can't do a line by line code review. However, and it's a big however, you can run automated code scanning tools and look for things. You might never find a back door, but you can absolutely find a coding error. By just running commercial tools, okay, in it. All right, so there's that minimum that you can do. Now, going back to my point is, I find open source libraries that include open source, applications that include open source libraries to be, in fact, more secure than applications that were built on or added to other commercial libraries out there that were bought. Because it's the commercial produced that is the biggest offender of bad coding. I wish somebody would write a really good analysis and look at it. But yes, we're finding more and more problems with open source. But the open source community has taken a security ethic on board years ago. OWASP is open source. If you're building code, you're building it to, you're a developer who's in tune with OWASP. And I see the integrity of open source code every time we pen test it. And I'm telling you, it's head and shoulders. So first of all, you are making a great point, Jen, that we inherit and there's only so much you can do with inherited. Here's my next point is write it down and put it in a risk assessment that this application contains X number of libraries that are open source. Here's all we could do about it and accept that risk. Or not, okay? Because that's the best that you can do. So do the best that you can do. Look at the libraries to the extent that you can, run automated tools against them, put it down in your artifacts and accept that risk and move on with it. But at least you know what you know, and that's my point. Rather than just, it's all open source, let's just trust it all. No, it's amazing. You just might find something by looking. So look, document, risk assess, and accept if that's what you want to do. But it's our lack of maturity by just accepting these libraries might obtain bad code. Let's at least document it, acknowledge it, and own up to it in the event that it's breached.
Another question is from Tom, which asks us if you can envision an agile engineering approach to this type of security, such as the quantification of security levels needed and incremental prioritization of improvement of security level.
Well, I think Tom's way ahead of this. Way ahead of this presentation. You're dead on, Tom. You're absolutely right. That's the beauty of looking at your DevOps, whatever you're using, Agile, Waterfall, you can pretty much build it to suit. And you can make it very sophisticated, or you can make it very simple. You can make it very streamlined, or you could make it very, step 1, step 2, step 237, intricate as you can. I don't have an answer for you other than full customization is absolutely what's encouraged, okay? And is understanding whether it's agile or where in the process is the best time and place to do what activities, and build those in yourself. The example I gave you was just an example. But they should be built with your developers based on the language, the approach that they're using, and take the minimum set of requirements and put them in the tactically the best opening possible, conducive to streamlining and doing them as quickly and as effectively as possible. But I suggest we all turn in for Tom's next presentation on how to do that, because I'd tune into that, Tom.
Our next question is, sorry, it goes up and down in case somebody else writes anything. Okay, I'm here. Okay, the next question is from Dalbir, which asks us about the approach coming to adopting off-the-shelf products, and if it's all right as much as possible, and then taking a bigger focus on patch management, or is it not realistic since development coding at some point will be expected even if we outsource our application developments and focus on patching?
Okay, two questions in there here that Delbert is a lot like Jen. We were talking about, you know, a lot of applications are built on open source libraries. If that's what you're referring to off the shelf, taking other libraries, compiling them and making them part of the design of your application, then yeah, my answer is the same. Document, know what you know, do as much as you can on the open source and accept the risk and move on. Now, off the shelf also has another, you're buying an application off the shelf, having somebody else maintain it, whether that's software as a service or, now that to me is a very different approach, because I have yet to see a software as a service provider or anybody with an off the shelf, I hate people who do those quotes, off the shelf application that is actually going to give you access to the design artifacts, that you could do a risk assessment, understand the attack vectors, and see the application on that granular level that you could map out the attack vectors. Now, if you can do that and outsource it, but patching is, we're all going on patches, right? This is how we're patching our way through this problem, and patching has led to 84% of the applications being co-opted, right? Patching ain't getting it done, as my grandfather used to say. Just is not happening. It's not good enough. So outsourcing to somebody to manage that and then patch it, that's what we're all doing. So I don't think, Delbert, that that's the answer. I'm saying now, but if you go back to these three steps I'm advocating before doing that pen testing to an outsourced third party, looking at this the way it was designed, doing a risk assessment and mapping out the attack vectors, and then testing against that, the purpose of the application, I think you're going to find that that's much more powerful. And yes, you'll still have the patching to do regardless.
Thank you, Richard. Thank you for answering all the questions. I think this one last question is the perfect way to also end the event. Well, people are asking if you have any books or materials or websites they can check and in which you write.
Yeah, well, that's a good. I wish I would. You know, we've done a white paper on this. I was trying to get my the last. Listen, guys, my email's richard.hollis@riskcrew.com. I have to say, for me, I look to OWASP for their leadership. I do count on them. These guys have been in this space for a long time. They've forgotten what most of us aspire to learn over the length of our careers. So I'm a big advocate, if you're not involved in OWASP, and all the resources that OWASP have. Now, having said that, you know, whether it's this simplified approach or how to pragmatically get more for your money in terms of your development team, how to integrate these activities into your team, or how to start to design artifacts that address these issues from the ground level up, I can certainly help you with that. I can't think of, we used to publish, I think I've got, you know, white papers on this that may be 4 or 5 years old, but they're certainly available to you. Anyway, my email is richard.hollis@riskcrew.com. You can get a hold of me through Dallam or Diana, or I would be more than happy to point you toward anything on a specific question if you're looking for specific help. But I'm just happy. Sorry, Diana. I was just saying, I'm just happy for the time to point you at this problem, because it's a lot easier. We could get a lot more, a lot farther, a lot quicker if we just took a very, very simplified step-by-step approach. I don't see us solving this overnight. Unfortunately, we don't have the money for, or we would have done it years ago. So I'm just looking for temporary solutions and things that we can pragmatically implement that make us better at what we do.
Unfortunately, just to answer the questions within the group chat, we don't have the link for the white paper right now, but I added your email address within the chat so people can just copy paste it from there.
Please do. Don't hesitate to reach out.
Dallim, back to you.
Okay, well, thank you very much, Diana. Thank you, David, as well, for doing your good technical management in the background. And the message from David is that the video of this conversation, of this event, will be available in a few days' time. So look out for that on our websites and our YouTube channel. Well, thank you to Diana and David. But of course, the main person is Richard. I'd really like to thank you very much, Richard, for again, another concise, to the point, and thoughtful presentation, which has left us with a lot of things we can address, but also pointed out some of the obvious. So that's really great. So please join me in thanking Richard.
Thanks, Tom. Thanks, Diana. Thank you, David. Appreciate it.
Thank you.
Great.
Bye.
And I have a couple of footnotes to add. Tom Gill, who is here, has been sending links to things like his books, like Quantifying Security, broadly relating to this topic, Basic Principles of Software Engineering, and so on. Also, Systems Enterprise Architecture. If you don't know Tom, well, you should. He is an absolute guru. He has been a hero of mine since about the 1980s, I think it is. Richard is also a hero of mine, but of a slightly more modern era. But Tom is very much a guru, very much a practitioner and developer of system testing methodologies. So do take a look at that. Now, somebody asked a question, what spread of countries and so on do we have people from on this call? And well, I'm quite amazed. It comes from way over in the east, from Tom, who is dialing into this from Norway, way over in the west to Central America, and then in the north-south spread, not quite so adventurous, up to Cambridge, I've seen in the chats, and also down to Cairo in Egypt. So, wow, do we cover ground? We certainly do. Do we bring you insightful and thought-provoking sessions? I hope we do. And if you've got any comments about that, please do put them in the chat or send them to us. And we look forward to seeing you next time. Thank you and bye for now.
Bye.